Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel is at smarturl.it/pass actuarial exams. Here you have information about online seminars and study manuals for exams PFM, IFM, and LTAM that I offer. I direct the Actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smarturl.it/help ISU Actuary. Here's a problem for today for exam P on the probability. At a mortgage company, 60% of calls are answered by an attendant. The remaining 40% of callers leave their phone numbers. Of these 40%, 75% receive a return phone call the same day. The remaining 25% receive a return call the next day. Of those who initially spoke to an attendant, 80% will apply for a mortgage. Of those who received a return call the same day, 60% will apply. Of those who received a return call the next day, 40% will apply. Calculate the probability that a person initially spoke to an attendant, given that he or she applied for a mortgage. And very important consideration is that you should immediately see that we are given a probability that is conditional about something, and the question asks for a conditional probability the other way. So let's look at this. For example, of those who initially spoke to an attendant, 80% will apply for a mortgage. This is saying that given that a person initially spoke to an attendant, the probability of applying for a mortgage is 80%. So the probability of applying for a mortgage conditional on the event that the person who initially spoke to an attendant is 80%. And then the question asks it the other way. What is the conditional probability that a person spoke to an attendant given that the person applied for a mortgage? Now, anytime you have this flip of conditional probabilities of first going one way and then the other way, it is virtually certain that the question asks you to use the Bayes theorem. And here's a solution. We start, as always, by labeling the event. So let's say M is the event that caller applies for a mortgage. S is the event that caller initially spoke to an attendant. R is the event that the caller had to leave the number and then the call is returned the same day. And N is the event that the caller had to leave a number and the call is returned the next day. We are looking for the probability of S given M, and then using the Bayes theorem we have probability of S given M is probability of M given S times the probability of S over the same expression as in the numerator, but for all parts of the partition of the probability space, and the partition consists of S, R, and N. And note that, of course, in the numerator, the conditional probability here is the flip version of this. So on the left-hand side, we have probability of S given M. On the right-hand side, we have the probability of M given S times the probability of S. That's the standard procedure. That's what Bayes theorem says. So this numerator with this standard procedure shows up at the bottom in the same form, but not just for S, but for S, R, and N, because these are the pieces of the partition of the probability space. Okay, now as we wrote this, we just plug in the numbers. For probability of M given S times the probability of S, this is straightforward, it's just 0.8 times 0.6, that's given in the problem. For probability of M given R times the probability of R, there's a little bit of extra work because we have a certain percentage of calls where the people leave a message, and then some of them leave a number, and some of them are called this day and some of them are called next day. So that's why we have these three probabilities multiplied out here, and then for next day these are the probabilities from the problem. And all we need to do is just now calculate it, and the answer is approximately 0.68571429, which is answer E. Please remember this is copyrighted material. The problem itself belongs to the Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.